Welcome to our tutorial on building scalable applications with MongoDB. In this video, we will explore how to leverage MongoDB's features to create a robust, scalable application architecture. Before we dive into the coding aspects, let's discuss why MongoDB is an excellent choice for scalable applications. MongoDB is a NoSQL database that allows for high flexibility with JSON-like document structures. This structure supports varying types of data and provides horizontal scaling capabilities which are crucial for large-scale applications. To illustrate our points, we will be creating a simple online bookstore application. This application will allow users to add, view, and delete books. We will also use a RESTful API architecture to interact with our MongoDB database. First, let's set up our development environment. You will need Node.js installed on your machine, as well as MongoDB. I recommend using MongoDB Atlas for our cloud database, as it simplifies setup and provides automated scaling. To install Node.js, visit nodejs.org and download the latest version suitable for your operating system. Once installed, you can verify its installation using the command. Next, let's create a new directory for our application. Open your terminal and run the following commands. The command npm init creates a package.json file with default settings, allowing us to manage our project's dependencies. Now, let's install the necessary packages. We'll need Express for our web server, Mongoose to interact with MongoDB, and CORS for handling cross-origin requests. Let's set up our basic server using Express. Create a file named server.js in your project directory. Open it and start with the following code. This code initializes an Express server, enabling CORS and JSON parsing for incoming requests. Now, we want to connect to our MongoDB database hosted on MongoDB Atlas. You'll need to create a free account on MongoDB Atlas and create a new cluster. Once you have your cluster, get your connection string from the dashboard and replace your connection string in the code below. Now that we've connected to MongoDB, let's define the schema for our books. Create a new directory called models, and inside that, create a file named book.js. Here's how to define a book model using Mongoose. This schema represents the book structure we will be using in our application. The next step involves creating routes to handle incoming requests. Create a new folder named routes, and inside that, a file called bookroutes.js. In this file, we will set up our RESTful API routes for handling books. With our routes defined, we need to incorporate them into our main server file. Return to server.js and add the following code to import and use the book router. Now that we have set up our API, it's time to test our endpoints. You can use Postman or any preferred API client. First, start your server with the command. Our server should be running, and you can navigate to http://localhost 5000/API/books. Initially, this should return an empty array. Next, let's add a book using the post method. You can send a JSON object like this. Confirm the creation of the book by checking the response. Repeat this process to add multiple books, allowing us to test our get endpoint to retrieve all books. In the next step, we will cover caching for improved scalability. Caching is a critical technique for improving application performance and scalability. While MongoDB can handle large reads and writes, implementing caching can reduce the load significantly. One popular approach is to use Redis as a caching layer. We will now integrate Redis into our application. Create a Redis client and modify our existing getAllBooks route to check the cache before querying MongoDB. Here is how it looks. In this modification, we check if the data is available in Redis. If it is, we send it back from the cache. If not, we fetch it from MongoDB, store it in the Redis cache for future requests, and then respond. This approach can drastically reduce the latency for read-heavy applications. As we build scalable applications, it's also essential to implement monitoring and logging. These features will allow you to track the performance of your application and help you diagnose issues before they escalate. You can use the Morgan package to log HTTP requests. In server.js, you can set it up like this. Now that we have logging in place, you can see all incoming requests in your terminal. This information is invaluable for understanding user interactions and diagnosing potential issues in your API. Scaling out your application involves setting up more instances. You can scale horizontally with container orchestration systems like Docker and Kubernetes. Here's a brief overview of how you can set up your application in containers. With Docker, you can build your application image and run it as a container. Kubernetes would help manage these containers, ensuring that you have enough instances to handle the load. Finally, let's look at deployment considerations. Services like Heroku and AWS provide great options to deploy your Node.js applications. If you choose Heroku, you can set it up with a single command. Once deployed, you can manage your application directly on the Heroku dashboard, including scaling and monitoring. In conclusion, we have successfully built a scalable online bookstore application using MongoDB. We covered everything from environment setup to implementing caching, logging, and deployment strategies. I hope you enjoy building your applications with MongoDB. Thank you for watching. Be sure to like, subscribe, and leave a comment if you have any questions or topics you'd like us to cover next.